Okay, 13.7. We're taking our sine and cosine functions and translating things and moving them around with an h and a k. Just like everything else that we've worked with, sine and cosine have h's and k's, where h moves things left to right and k moves things up and down. And you do the opposite of h but keep the same k. Meaning if h was a negative number, you move to the right, and if h is a positive number, you move to the left, so it kind of feels backwards. We still have our amplitude found by the letter A. We still find our period by doing 360 over B. B itself is not your period, it just helps you find your period. If the A value is negative, everything will reflect. And then there's translations by H and K, and there's a starting point HK, and you'll see all that in a second. So we'll graph y equals the cosine of x plus 3. Here's what I do, and I really recommend you do this as well. Think about this plus 3 right here like it's moving your new axis up 3 units. So my x-axis is still going to be here. This is still my x-axis, and that's still my y-axis. But now I think about 1, 2, 3, 4. The whole graph is now centered around this 3 instead of being centered around the x-axis like it was before we started moving things. Let me explain why that is. If you think about cosine, if I do just plain old cosine of x, or cosine of theta, same thing, we would plug in numbers for our theta or for our x, whichever variable you want to call it. We'd plug in 0, 90, 180, 270, 360. Those are all my inputs. Well, the cosine at 0 is 1, cosine of 90 is 0, cosine of 180 is negative 1, 0, 1, and then that pattern repeats. So you'd have 0, 1, I'll keep that kind of same scale I kept before, so I'll go 0, 90, 180, 270, 360. So here's 180, 270, 360, 450. So this one here is 540. Cosine's going to go high, middle, high, middle, low. So high, middle, high, middle, low. And it makes this wave. Well, that was plain old cosine without the plus 3. That was assuming we had cosine without the plus 3. If we tack back on that plus 3, the graph is going to move up 3 units. It was here, now it's here. The plus 3 just translates it up 3. So what I do instead is, when you graph this on paper, you don't have the luxury of actually sliding these graphs around. You could if you wanted to. I wouldn't mind if you graphed plain old cosine and then moved it around and graphed it again. But it's easier to think, okay, here's my center, here's where I'm starting this graph. Cosine goes high, middle, high, middle, low. And just pretend like this new orange line is my x-axis. Middle, high, middle, low. It's like that. So that's how that curve would look. Oops, excuse me, I meant to erase that. The curve should be looking like this. It's cosine of x plus 3. Here's cosine of x minus 90 over on the right. Well, this time the graph wasn't moved left or right, it was moved up and down. So I'm going to it was moved to the right. The whole graph is moved to the right. So I'm going to start here at the cosine of 90. Well, cosine, again, starts high, and it's going to go up all the way up to 1, because the amplitude here is 1. So it goes high, middle, high, middle. This is middle, high, middle, low, middle. And this is going to be this graph. It's right there. Again, we could make a table if we wanted to. I could make the same old table I usually do, 0, 90, 180, 270, 360. But when I plug in a 0, it becomes 0 minus 90, so I'm really doing the cosine of negative 90, and the cosine of negative 90 is 0. So that's why I have the point 0, 0 right here, which I kind of missed on my graph. So I plug in a 90, the cosine of 90 becomes the cosine of 0, because I'm doing 90 minus 90 to get 0, and the cosine of 0 is 1, so that's the point 91. You'll notice cosine of x minus 90 is actually the exact same as sine of x. It's a phase shift, we call it. When you move things left to right, that's called a phase shift. And you can phase yourself from cosine into sine. That's pretty much why these are always called sine waves and not cosine waves, because cosine wave is just another way of finding a sine wave. All you really need is sine to accomplish whatever you want. but a cosine phased to the right 90 is sine. If cosine was phased to the left 90, here's regular cosine, phased to the left 90, would actually give you a negative cosine wave, which looks just like a regular cosine wave. But there's that. Okay, we'll get a bit more complicated now. This has an amplitude of 3, and it's been moved down 2 units. So I'll draw my new x-axis, basically, starting at -2. I'll still count by my theta of 90s. So I'll go 90, 180, 270, 360. This is a sine function. Sine starts in the middle. So sine is going to start here, and then it goes upwards. I mean, a sine graph, as sine increases, the sine of 0 is 0, and the sine of 90 is 1. But that 90 is then multiplied by 3. I'm sorry, that 1, the sine of 90 is 1. So 3 times the sine of 90 is 3. And 3 times the sine of 90 minus 2 actually gets us back down to 1. So I'm going to go all the way from here. My amplitude is 3, so I go up 3 units. This space here has to be 3 units. So I go up 3 units, then back to the middle, then down 3 units, then back to the middle, then up 3 units, then back to the middle. So that's why I call this high, middle, low, middle, high, middle, low, middle. And this sine wave is bigger and therefore a bit more stressful to graph. It looks like that. And if I want to do this in radians instead of degrees, I could just take all these degree measures and convert them into radians. There's pi over 2, and there's pi, and there's 3 pi over 2, and there's 2 pi, and it would go like so. Next one, this one was given to us in radians. Since it has a pi in it, this one's in radians. And this has a lot going on. It has a reflection. This negative a value here reflects things. It has a phase shift to the right pi units, and it has a movement up 1. So I'll start by going up 1. And then before I do anything else, before I even put on my new little y-axis, I'm going to think about the period. The period of this graph is 2 pi. Oops, excuse me. There was no change to the period. So the period of this graph is 2 pi. So from my center, and I'll just put pi, here. No, I'll count by pi over 2s. We usually count by pi over 2s. So I'll put pi right here. So this is pi over 2, this is 3 pi over 2, and this is 4 pi over 2, and this is 5 pi over 2, and this would be 6 pi over 2. So my graph is now going to be centered here at pi over 2, comma 1. Pi over 2, comma 1. Sine starts in the middle. Sine doesn't start high or low, sine starts in the middle. And usually sine goes up. It would do something like this. But because we have this negative, sine's going to do the opposite. It's going to start by going down. So I don't go middle, high, middle, low. I go middle, low, middle, high. Although my spacing there was off. Middle, low, middle, high, middle, low. So I'll go low, middle, high, middle, low, middle, high, middle, low. I think I can do better. I made these reds, they're kind of tough for me to see. I should have picked a color that's not so orangey. But low, middle, high, middle, low, middle, high, middle, low, middle, high, middle, low. Sure, not bad. Could be better, but it's not bad. So everything was moved to the right pi units. So I basically figured, what am I counting by? That's kind of what becomes the hardest part, is your scale, which is spelled like this. What are you counting by? Once you figure what you're counting by, in this case I wanted to count by pi over 2s because the period didn't change, then I could know where to put my hashes and how to go from there. So now we'll do one where the period does change. In fact, I think I can skip this one, and we'll jump to, and none of these does the period change. I think that means that I won't change your period and change your phase shift at the same time. So don't worry about both of those changing at once. I'll either change just the period or just the phase shift. But just to be sure, just to be safe, let me change this problem. Let's make this y equals -2 times the cosine of, and it looks kind of weird when you have to write this. Let's put a 2 here. Let's put a 4 here. In fact, let me pause and think if I want to do this or not. 1 second. Yeah, I want to do one of these just to make sure we can handle this, or at least so that you've seen it before. So everything now is happening. There's a change in the amplitude, there's a reflection, there's a change in the period, there's a phase shift, and there's a vertical shift. So to kind of break those down, I'll go with my thin pen. Here's the reflection, here's the amplitude change, here's the change in the period, here's the phase shift, and then here's the vertical shift. I'm going to take care of all these things at once. So before I start graphing anything, I'm going to figure what's my period and what do I count by. Usually, a period of a sine or cosine function is 2 pi. But when we're going to find our new ones, we do 2 pi over b. So right now, our period is 2 pi over 4, which is actually a pi over 2. That means that every single time we go through a cycle, it takes pi over 2 radians to travel. Well, to find your scale, this is the best little trick I have here. Remember how we've always done 1, 2, 3, 4, 5 hashes. We've always put down 5 hashes. Well, that really means that I would take this pi over 2 and to find my scale, divide it by 4, or multiply it by 1/4, because from the first point you're adding 1, 2, 3, 4 spaces. So if there's 5 spaces, you divide by 4 because you're taking 4 steps. From the first point, you're adding 4 spaces. So I'm going to count by pi over 8s. My scale is going to be by pi over 8. So here's 0, here's 1 pi over 8, here's 2 pi over 8, which is pi over 4, here's 3 pi over 8, 4 pi over 8 is pi over 2, 5 pi over 8, and 6 pi over 8 is 3 pi over 4. Then everything was moved to the left pi over 2. Well, I should have gone negative, I suppose. Here's a negative pi over 8, a negative 2 pi over 8, a negative 3 pi over 8. It's supposed to be a pi over 4. Let me fix that. 2 pi over 8 is pi over 4. A negative 4 pi over 8, which is a negative pi over 2, and then here's negative 5 pi over 8, and negative 6 pi over 8. I'm starting this graph left pi over 2 and down 1. So my graph is going to be centered around those 2 orange lines. This is basically my new origin. It's not actually the origin, I just think about it that way because that's how I'm going to graph. Now everything else takes care of itself. All that I have to worry about is the amplitude and the fact that we start by going down, or no, I'm sorry, this is a cosine graph. So we reflect it. Cosine usually starts low because, or I'm going to say that again. Cosine is usually high. Cosine is usually at the point 0, 1. But because it's negative, it's going to start at 0, negative 1. Basically, instead of starting high, cosine is going to start low. And it's going to start low by an amplitude of 2. So I start down 2. Usually cosine would start up here at up 2, positive 2, but it doesn't. It does down 2. And then I can just do my pattern. Low, middle, high, middle, low, excuse me. Low, middle, high, middle, low, middle, high. Doom, 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 doom. Try and make these curvy and not liney. And there's my cosine graph. Whew, that took some work. Just to check, if you want to kind of see how this is looking on your computer and your calculator, I'll do negative 2 times the cosine of 4, and then in parentheses, x plus pi divided by 2 double close parentheses, minus 1. And I'll make the window of this graph look like the window of the graph that I drew. So from negative 3 pi over 4 to 3 pi over 4. And my scale, I was counting by pi over 8s. From the y's, I'll go from negative 5 to 5. Count by 1s. Graph that. And I want to check to see, like, is this y-intercept here? Does that match my y-intercept here? It totally does. So things are looking good. There we go. That's graphing with sine, cosine, tangents, and the other phase shifts. We'll do tangents next. Sorry, just sine, cosine first. Stop talking, Grant.